So here's a short video about how to compute the tangent line to a curve at a point. Okay. Tangent line. Okay, so the tangent line often referred to a curve, okay, with respect to a point. Okay, a point P over here is, use 2D as example, is x, y, okay, and the curve typically can be represented by a vector, also in 2D, x, t, and y, t, okay, okay, and the point also represents a certain point, okay, it's pointed on the curve, so it should be able to represent it by x, let's say t star, if I use this one, and y, t star. So as we mentioned in class, so the tangent line is the line which only intersects with the curve at this point, which means the tangent line is sort of the line only intersect with this one. Let me draw it more carefully. Only intersect at this point with the curve. Okay. The computation, the line can be represented by in this form. The line, the tangent line is represented by the point itself, x, t star, y, t star, okay, and plus the derivative is x dot of t, and also derivative of y dot t, and evaluated at t is t star, is a point which one want to find the tangent line time t. Okay, so the differences between this t, so this t you try to evaluate to get the derivatives. The derivative is computed by dxt over dt, and this y dot t is dyt dt, and then you evaluate at this specific t star, and you time t. So this t and this t, they're different. Okay. For example, I mentioned in class, okay, which is my xt and yt, which is given by, is a curve, is given by t and t squared. Okay. And if you compute the tangent line at t equal to 1, which means that t star is 1, okay, so my tangent line is t, I use tangent line to represent t, tangent line is given by a point, right? I want to find the points, which means the point will be x, t star is 1, so x1, y is 1, plus the derivative. So derivative of this guy, each one with respect to t. So the first one is t, the derivative of t with respect to t is just 1. The derivative of t squared with respect to t is 2t. So then we have to evaluate this value at let t to be equal to t star. So essentially this is just to calculate, the direction of tangent line. Now we have to do time t, because if you don't have time t, let's just give you a point, because this guy x1 this is just 1, and x1 y1 is also 1. By calculating this xt by letting t to be 1, and t squared by letting t to be 1, you get a 1 and 1. Okay, so essentially the first one, try to calculate the point. As I mentioned over here is a point. This is the point that I calculate. The first one, this is the point. Okay, the second one is try to calculate the second term, this one without a t. the first one is just, as the second one, this just calculate direction. This is direction. This is x dot t, y dot t, evaluated at t is t star. So by timing this t, we'll actually get many points, numerous points here. If you allow the t to be negative, you also go this way. So that will define the line. That's why we have a t over here. So this t has nothing to do with this t inside the t, because this t will be evaluated at t star. So this says no, this will be constant, it will be some numbers. So that's why we still have the t to make sure that this will create a line, because we can't let t change. T can change from some value, let's say from 0 to 10, it will create a line, right? If you don't have this one, you won't be able to create a line. Okay, that's the tension line. I hope that's helpful.